So we have an OCR Chemistry A, F321 past paper here from January 2009. So question number 1. Carbon occurs in a wide range of compounds and is essential to living systems. 2 isotopes of carbon are carbon-12 and carbon-13. State what is meant by the term isotopes for 1 mark. So you need to put atoms of the same element with different number of neutrons, and that'll get you the full mark. So part 2. Isotopes of carbon have the same chemical properties. Explain why. So all you need to put is same number of electrons. So if you put same electronic configuration or same electron structure, you get the mark as well for that one. So part 3, define relative isotopic mass. This is worth 2 marks. So you need to put mass of the isotope compared to 1/12, and that get you 1 mark. I need to put mass of a carbon-12 atom to get the second mark. So you need to put mass of the isotope compared to 1/12 for 1 mark, and for the second mark you need to put mass of a carbon-12 atom. So we've got question 1b. One form of naturally occurring carbon is graphite. The table below lists some properties of graphite. So you've got talking about electrical conductivity, hardness, and melting point here. So describe the bonding and structure in graphite. Explain, in terms of bonding and structure, the properties of graphite shown above. In your answer, you should use appropriate technical terms spelled correctly. So that's what this pen here stands for. So if you spell a key term wrong, you could potentially lose a mark. Okay. So first thing you need to talk about is what type of bonding and structure does graphite undergo. So graphite undergoes giant covalent bonding, forming a lattice structure which forms layers. Okay, so spell lattice wrong, so make sure you get keywords spelled correctly. So that would get you 2 marks. I'll show you where your marks come from in a second. So you need to explain each of the properties. Okay, so first of all we'll talk about conductor. And the reason graphite is a good conductor is because it has mobile electrons. So graphite has mobile electrons which can carry a charge. Okay, so next point, high melting point. So this is because it requires a lot of energy to break those strong covalent bonds. So strong covalent bonds require a lot of energy to break. The next point we need to cover is soft. And the reason graphite is soft is because those layers can slide over each other, and that makes graphite soft. So because the layers can slide. So where do we get these points from now? Where do we get these marks? So we'd get 1 mark for saying giant covalent bonding. We'd get another mark for saying layers. We'd get another mark for this explanation, we get a mark for this explanation, and we'd also get a mark for this explanation, giving us a total of 5. But any keywords, especially in this mark scheme, it's saying electrons have to be spelled correctly. If you hadn't spelled electrons correctly, they would deduce a mark off you. So question 1C. In the 16th century, a large deposit of graphite was discovered in the Lake District. People at the time thought that the graphite was a form of lead. Nowadays, graphite is used in pencils but is still referred to as pencil lead. A student decided to investigate the number of carbon atoms in a pencil lead. He found that the mass of the pencil lead was 0.321 grams. So, calculate the amount in mole of carbon atoms in the student's pencil lead. Assume that pencil lead is pure graphite. So, here the key information is this mass number here. So 0.321 grams. The rest need to calculate moles and also carbon. Okay, so moles, we can use this equation. Moles is equal to mass over mR. So we know the mass number is 0.321, and from our periodic table, the atomic mass for carbon is 12. That gives us a calculator value of 0.02675. Now, always give your answer to an appropriate number of significant figures, and in this answer, I'd give it to 3 significant figures. Reason being is this is given in 3 significant figures, and as long as you've got that, you've got 1 mark. Okay. They also would allow 0.027 for this answer. So for the next part, using Avogadro's constant, Na, calculate the number of carbon atoms in the student pencil lead. So Avogadro's number is 6.02 times 10 to 23. Okay, and from my previous question, we've got the number of moles. So all we need to do is times Avogadro's number by the number of moles, and that will give us the number of carbon atoms. So Avogadro's number times the number of moles from the previous question, and we should get an answer of 1.61 times 10 to the 22. And that is for 1 mark. Okay, you would get error carry forward, so if you did this answer wrong but you did this calculation right here, you would still get the 1 mark. So question number 2. Chemists have developed models for bonding and structure which are used to explain different properties. Ammonia, NH3, is a covalent compound. Explain what is meant by the term covalent bond. So for this, all you need to do for 1 mark is put a shared pair of electrons. Okay, so part 2 is asking you to draw a dot and cross diagram to show the bonding in NH3, and this is worth 1 mark. So we know from the question above that it's covalent. Okay, so we know that nitrogen has got 5 electrons in its outer shell, and we know that hydrogen has got 1 electron in its outer shell. So we need 3 hydrogens. Which each have an electron. And then we need to give our nitrogen 5 electrons, so we can do 1, 2, 3, 4, 5. Okay, so got a lone pair of electrons on your nitrogen. So we've got shared paired electrons here, covalent bond here, and another shared paired electrons there. So you need to have that diagram for 1 mark. So part 3. Name the shape of the ammonia molecule. Explain using your dot and cross diagram why ammonia has this shape and has a bond angle of 107 degrees. So now you need to state the shape first of all, and this shape is pyramidal. That'll get you a mark. And then you need to explain why. Okay, so basically the reason it's pyramidal is that there are 3 bonded pairs. You've got 1, 2, 3 bonded pairs and 1 lone pair, which is this pair of electrons at the top from your nitrogen. And then you need to say that lone pairs repel more than your bonded pairs. And that's what you need to put for your 3 marks. So, where your marks come from, you get a mark for that statement, a mark for this statement, and a mark for that. And that's all you need to put for your 3 marks. So question 2b. Ammonia reacts with hydrogen chloride HCl to form ammonium chloride NH4Cl. NH4Cl is an ionic compound containing NH4 plus and Cl minus ions. Complete the electron configuration of the Cl minus ion. Now they started it off for you, so they're giving you a clue for what they're asking for. On the periodic table, chlorine has got 17 electrons, but this is an ion, okay? Remembering that if it's got a minus charge, it's gained an electron. So we need 18 electrons in our electron configuration. So we've got 1s2, 2s2, remembering to write the numbers to the power, 2p6, 3s2, 3p6. Now if we total these numbers up, they equal to 18, and then that would get you your 1 mark. So question B, part 2. Draw a dot and cross diagram to show the bonding in NH4+. Show those outer electrons only. So we go back to our previous question where we had ammonia. We had nitrogen, where we had 2 lone pairs, and then we had 3 covalent bonds formed with hydrogen. Remembering hydrogen's got that 1 outer shell electron. Now here we need to put a hydrogen on this place here, but this forms a dative covalent bond. The reason being that your hydrogen has lost its outer shell electron. That's why ammonium has this plus charge, so therefore needs 2 electrons. Those 2 electrons come from your nitrogen, meaning it's a dative covalent bond. You need to draw your square brackets, and then that gives you ammonium, and you need to draw that for 1 mark. So part 3. State the shape of and bond angle in ammonium ion. So the shape is we've got 4 bonding regions. So we've got 4 bonding regions. The shape must be tetrahedral. And hopefully by now we should all know that the bond angle for tetrahedral is 109.5 degrees. So 109.5 degrees, and that would get you 2 marks. So simply stating the shape and the bond angle. So part 4 this time. Student investigated the conductivity of ammonium chloride. She noted that when ammonium chloride was solid, it did not conduct electricity. However, when ammonium chloride was dissolved in water, the resulting solution did conduct electricity. So this is explaining properties of ionic compounds. Remember, it told you it was an ionic compound earlier up in the question. So just need to explain these properties. And when it's a solid, you need to say that those ions and or electrons are not free to move. And then you need to talk about when it's dissolved or when it's a solution. Okay, so solution, those ions are free to move now. So as long as those ions are free to move, or they're mobile, they can carry that charge, can't they? Whereas when it's solid, they're not able to do that. So you need to put both of those statements in order to get those 2 marks. So you need to talk about when it's a solid, and you need to talk about when it's a solution. Because it's asking for 2 marks, it wants 2 points of you, and you need to explain in order to get those marks. So question 2, part C. Ammonia compounds, such as ammonium sulfate, can be used as fertilizers. Write a balanced equation to show how ammonium sulfate could be formed by the reaction between aqueous ammonia and sulfuric acid. Okay, so ammonia, the formula for ammonia was given in the question previously, so we know that is NH3. Sulfuric acid, hopefully we all know that one, H2SO4. It's telling us what we form over here, so we need to draw the arrow and then write the formula. Okay, but it wants a balanced equation. Now this is where a lot of people go wrong. So nitrogen, we've got 1 on this side, we've got 1 here, but it's times by 2, so we need to have 2 nitrogens on this side. Let's check our hydrogens now. We've got 2 times 3, which is 6, 7, 8, 2 times 4 is 8, so our hydrogens now balance out, and we've got 1 SO4, SO4, so everything now balances. So it's 2NH3 plus H2SO4 plus ammonium sulfate for the 1 mark. Part 2. Ammonium sulfate is an example of a salt formed when an acid is neutralized by a base. Explain what is meant by the term salt. So it just wants a definition of it this time. So what is meant by the term salt? When the H plus in an acid is replaced by a metal ion. And that's all you need to write for the 1 mark. Simple definition for the salt. So part 3. Why is ammonia acting as a base in this neutralization reaction? So we know the definition of a base is a proton acceptor. And if we'll have a look at this ammonia here, we've gone from ammonia to ammonium. It's accepting a proton, it's accepting a hydrogen. So simply, all you need to write is it accepts a proton. And that'd get you the 1 mark. So part C, part 4. What is the relative formula mass of ammonium sulfate? So this is where you need your periodic table. So from a periodic table, we know that the mass, relative molecular mass of nitrogen is 14, hydrogen is 1, sulfur is 32.1, and oxygen is 16. Now it's just adding these numbers up. So we've got 2 times 14, add 2 times 4, add 32.1, add 16 times 4. And that gives us a sum of 132.1. And that is the answer for 1 mark. So just check your periodic table. You need your relative mass numbers. So for nitrogen it's 14, hydrogen it's 1, sulfur it's 32.1, and oxygen is 16. You just add them all together, and that gives you 132.1. And that's the end of question 2. A student used the internet to research chlorine and some of its compounds. He discovered that seawater contains chloride ions. The student added aqueous silver nitrate to a sample of seawater. So for question 3a, what would the student see for a mark? So we know from the laboratory experiments with silver nitrate and halides that we have chloride ions. We should get a white precipitate. And if you put white precipitate or white solid, you would get the mark as well. For part 2, write an ionic equation including state symbols for the reaction that occur. So this is worth 2 marks. So to get the full 2 marks, you need to do the equation and add the state symbols. So chloride, we know, is Cl minus. And it's in a solution, so it's going to be aqueous. And it told us up here that we had an aqueous solution of silver nitrate. We know that silver is Ag plus and nitrate is NO3 minus. So we're going to have Ag plus, aqueous, goes to AgCl, solid. And the reason it's solid is that we get this precipitate formed. And to get both marks, you need to get the correct state symbols and the correct equation. So for question number 3. After carrying out the test in part 1, the student added dilute aqueous ammonia to the mixture. What would the student see? So what would happen if we added ammonia to this white precipitate? All that would happen is that precipitate would dissolve. In the case of chloride ions. So part B. The student also discovered that chlorine, Cl2, is used in a large-scale treatment of water. State one benefit of adding chlorine to water. And that's for 1 mark. So I always like to put that it kills bacteria. But it could also have sterilizes water, makes water safe to drink, kills microorganisms for you biologists out there. Any one of those for 1 mark. So B part 2. Now everyone agrees that chlorine should be added to drinking water. Suggest one possible hazard of adding chlorine to drinking water. So for this one, I always put toxic. Or you could put causes cancer through those chlorinated hydrocarbons. Or you could put poisonous. Any one of those for that 1 mark there. So now it's bringing in some redox. So part C. The equation for the reaction of chlorine with water is shown below. Part 1. State the oxidation number of the chlorine in Cl2, HCl and HClO for 1 mark. So you need to get all these oxidation states correct in order to get the full marks. So this is where we use, under my face, ho, its chin. So we have an uncombined element when combined with itself is 0. We have HCl, so we have Ho, hydrogen, its chin, Cl. So hydrogen comes before Cl. So hydrogen is usually +1. We've got an overall neutral compound, so Cl must be -1. Here we have under my face Ho, so we've got HO. So hydrogen comes before oxygen, so we've got +1, oxygen is -2. So in order to get the overall neutral compound, we need chlorine to be +1. And you need to get all these 3 oxidation states correct to get that 1 mark. And C part 2, the reaction of chlorine with water is a disproportionation reaction. Use the oxidation numbers in part 1 to explain why. So you've got 2 marks here. A disproportionation reaction is something that's where oxidation and reduction is occurring in the same element. So you get 1 mark for just stating chlorine has been oxidized and reduced. And for the second mark, you need to use oxidation numbers. It tells you here, use oxidation numbers to explain why. So when it's been oxidized, it's gone from 0 to +1. And when it's been reduced, it's gone from 0 to -1. And that's what you need to put for both those marks. So you get your mark from here, stating this here, and then you need to state both of the changes, oxidise and reduction, to get your full 2 marks. So C, part 3. Chlorine reacts with sodium hydroxide to form bleach in another disproportionation reaction. Write an equation for the reaction for 1 mark. So, chlorine, we've got the formula in the above question before in part 3, and we should know the formula for sodium hydroxide as NaOH from our acids module. Now, in a lot of these reactions, we always get water formed. And some of you will be able to see here that Na, when it's broken up into its ions, is Na plus and OH minus. And that Cl minus can replace your OH. So we get this Na, Cl. And the formula for bleach is NaClO. And that's one to learn, because that crops up quite a bit in a few of the past papers. So, part D. 2 of the chlorine compounds, chlorine dioxide and chloric acid. Chlorine dioxide is used in a bleaching agent in both the paper and the flower industry. When dry, chlorine dioxide decomposes explosively to form oxygen and chlorine. Construct an equation for the decomposition of ClO2. So decomposition means breakdown. So breakdown of this ClO2. Now if we break this up, we get Cl2 and O2. Now this doesn't balance at the minute because we've only got 1 Cl on this side and 2 Cls over here. So we need to put a big 2 in front of this, which now means our oxygens doesn't balance out. So we have O2, 2 times 2 is 4. We need to have another big 2 in front of this one in order for that to balance. Now if you halved all this, you'd also get the mark as well. So D, part 2. Chloric acid has the following percentage composition by mass. Using the information above, calculate the empirical formula of chloric acid. Show all your workings. You have to show everything in order to get the marks. So empirical formula is that simplest whole number ratio. So first thing we need to do is get these percentages. So 1.20 for hydrogen over its molecular mass, which is 1. 42 over Cl, which is 35.5. And oxygen, which is 56.8 over 16. Now you do the math for that, you get 1.20, 1.18 and 3.55. So you'd get 1 mark for just doing that little bit there. So you divide by the smallest. Okay, so the smallest is 1.18. Which is 1 here, 1 here, and you get 3 for this. So your formula is H1 Cl 1 O3. And it's vital that you put this formula down and you don't just leave it like this because you wouldn't get the mark. You have to put the formula. So that is where your second mark comes from to get those full 2 marks. So show all your working. It's worth, even if it doesn't state it, to show your working anyway, because if you make a mistake in this formula, you can still get a mark for this bit above. And what does the phi represent in the chloric acid? This here just represents the oxidation number of your chlorine. And it's important you put which element it represents. So it's the oxidation number of the chlorine to get that 1 mark. So question 4. The table below shows the melting points and atomic radii of elements in period 3, sodium to chlorine. So Part A. Explain the difference in melting point for the elements sodium and magnesium. So we've got sodium here is 98 degrees and we've got magnesium as 639 degrees, and this is a 3-mark question, so you need to have 3 points. So magnesium's group 2. When it forms ions, it loses 2 electrons to get that magnesium 2+. Sodium's in group 1, so it loses 1 outer shell electron to form that sodium plus ion. So for 3 marks, you need to explain the differences in these, and that's because magnesium ions have a greater charge. Magnesium are 2+ ions, whereas sodium is 1+. And to get there, magnesium has more delocalized electrons. It's lost 2 electrons compared to sodium losing 1, and because of this, magnesium has stronger metallic bonds. You need to put those 3 points in to get the 3 marks. Now you can do the reverse argument with regards to sodium to get the 3 marks as well. So part 2. Sulfur exists as S8 molecules and chlorine as SCl2 molecules. Use this information to explain the difference in their melting points. We've got 113 for sulfur, minus 101 for chlorine. So, again, 2 marks. You need to put 2 points. So we know that Cl2 and S8 both have intermolecular forces. Both have intermolecular forces. They're both undergoing covalent bonding. Okay, so those intermolecular forces must be van der Waals. Okay, and that'll get you 1 mark. Now SA has got more electrons compared to chlorine. So if SA has got more electrons, we're going to have stronger intermolecular forces because we've got more van der Waals. That's why this melting point up here is 113 degrees compared to chlorine, which is minus 101. There's more van der Waals forces to break in S8 compared to Cl2. And that's all you need to say for the 2 marks. So B. Explain the decrease in the atomic radii across the period from sodium to chlorine. In your answer, you should use appropriate technical terms spelt correctly. So this is where you get marks now for using correct spelling of key terms. Anything with a pen like this, just keep your eye out for what they're asking you for. So as we go across, why does that atomic radius decrease? Okay, in that table again, atomic radius is decreasing. And as we go across the period, from left to right, we have the number of protons is increasing. Okay, that nuclear charge is increasing. So you need to say proton number is increasing for 1 mark. And then we need to talk about electrons, because if protons are increasing, so is that electron number. So electrons are added to the same shell. So as we go from left to right, electrons are added to that same shell. So there's no more shielding than the other elements. There's literally all the same shielding, same shells. Okay. But because we've got that greater proton number, the outer shell electrons are going to be experiencing a greater pull as we go more towards the right of that periodic table. So there's a greater attraction, okay, as we go from left to right. So those electrons are held more tightly towards the right of the periodic table compared to the left. And that's why the atomic radii decreases, because you're holding them in more, those shells are being pulled in more. Okay, and that's what it is for your 3 marks. And you need to spell protons correctly for making sure you get that mark here. So as long as you spell proton correctly, you still get this mark here. Question number 5. The group 2 element, barium, is silvery white when pure but blackens when exposed to air. The blackening is due to the formation of both barium oxide and barium nitride. The nitride ion is N3-. For question A, predict the formula of barium oxide and barium nitride for 2 marks. So, barium oxide. Barium is group 2. So barium has an oxidation state of 2+. Oxygen is 2-. So in order to get these charges to cancel out, we just need one of each. So the formula of barium oxide is BaO. So here in the question it's telling us what charge, what oxidation state that nitride has got, that N3-. So to get 2 and 3 into the same number, we need to get them both into 6. We need to get both a 6 charge on each of these elements. So barium, to get that 2+ to 6, we need to times it by 3. And for the nitride, to get that 3 into 6, we need to times it by 2. And that's the formula for barium nitride. You can get a mark for that one and a mark for getting that one right. So B. A 0.11 gram sample of pure barium was added to 100 centimeter cubed of water. Show that 8.0 times 10 to the minus 4 moles of barium were added to the water for 1 mark. And that's just this equation. Number of moles equals mass over molar mass. So we've got the mass, which is 0.11, and the MR of barium, which is 137.3. And if you put that into your calculator, you should get 8.0 times 10 to the minus 4. And that's all you need to show for 1 mark. So part 2. Calculate the volume of hydrogen in centimetre cubed produced at room temperature and pressure. So again, we're using this equation, N equals V over 24,000. The reason it's 24,000 rather than 24 is that they want it in centimetre cubed. Now, above here, we've got the number of moles of barium. If we look at our equation, the molar relationship between barium and hydrogen is 1:1. So we have 8.0 times 10 to the minus 4 moles of hydrogen. All we need to do is rearrange this equation by bringing this up and timesing it by a number of moles. So just do that times 24,000. If you work that out in your calculator, you should get 19.2 centimetre cubed for a mark. So the next bit, part 3. Calculate the concentration in moles per decimetre cubed of barium hydroxide solution formed. So as soon as they say concentration, we've got a volume up here as well. You should think of N equals C times V over 1,000. But what they want us to do this time is to calculate this concentration. So we need to rearrange this equation by bringing 1,000 up and volume down. So we have concentration is equal to number of moles, which again we use the one we had originally. Barium is 8.0 times 10 to the minus 4, 1:1 molar ratio. So we have 8.0 times 10 to the minus 4 moles times 1,000 over 100. The reason we times it by 1000 is that we want to go from centimetre cubed to decimetre cubed. And if we put that into our calculator, we should get 8.0 times 10 to the minus 3 moles per decimetre cubed. And state the approximate pH of barium hydroxide. Now we know barium hydroxide, if you think of sodium hydroxide, it's got to be an alkali, so it's going to have a pH of anywhere between 7 and 15. So as long as you put a number between 7 and 15, you'll get the mark. So I'm just going to put 8, and that's for a mark. So 5 part C. A student repeated the experiment in part B using a 0.11 gram sample of barium that had blackened following exposure to the air. Suggest why the volume of hydrogen produced would be slightly less than the volume collected using pure barium, for 1 mark. So if we've got barium oxide compared to pure barium, we're going to have less barium to react, and that's simply all you need to state for 1 mark. So there's just less barium to react. So if there's less barium to react, we're not going to get as much hydrogen produced, and all you need to say is that for 1 mark. So 5 part D. Describe and explain the trend down the group in the reactivity of group 2 elements with water. So this is where you use ESPNAI. Electron shielding, shells, proton number, nuclear attraction, atomic radii, ionization energy. You need to put at least all of these points in order to get these 5 marks. So as we go down group 2, we're talking about trends with reactivity with water. So the first thing you need to state is that reactivity increases, and then explain why. So why does that reactivity increase? Because as we go down the group, that atomic radii gets larger. Increases if we're using more scientific terms, so atomic radii increases because we've got more electrons, more shells, okay? And because that atomic radii is increasing, we're getting an increase in shielding, in electron shielding. And if we have an increase in electron shielding, that attraction between the outer shell electron and that nucleus decreases. So that nuclear attraction decreases. And because that nuclear attraction is decreasing, you're not going to need as much ionization energy to remove that outer shell electron. So it's easier to remove that outer shell electron, so ionization energy decreases. So we can say easier to remove outer shell electron slash ionization energy decreases. So let's see if we've covered all our points. So electron shells, we've talked about that in atomic radius. Shielding, we've covered that point here. Protons, we talked about nuclear attraction here. I missed it off. So nuclear attraction decreases. This is why it's good to check your answers, okay? So nuclear attraction decreases, atomic radii, we've covered that there, and ionization energy we've covered in this last point. So for all those 5 marks, you need to have covered these points here, and reactivity for the last one for 5 marks. And that's the end of the paper.